Coders, welcome to this video. In this video, we are going to study about the dangling pointer. So this is very interesting topic. So it's a part of debugging in our code. A lot of times we got stuck and not able to find where the problem is. So the problem may be due to this dangling pointer. So first we need to know what is the type of problem that is produced when this dangling pointer issue comes. After that, we'll see what is the after effect of this dangling pointer. So first, we need to check what is a dangling pointer. So when we allocate some memory to a pointer and we free that memory, and after freeing that memory, if we're trying to access the pointer which already have the address of the memory that we already freed, then there is some random things or random crashes that occurs in our system. So this is the after effect of this dangling pointer. So there are different types of issues that is created through this dangling pointers. So I listed three of them. So first issue is if we return a pointer to the local variable from the function and we try to access that memory, that is also a type of a dangling pointer. So let's start from the first type. Let's produce this one dangling pointer. Okay. So what I do, I will take a char star get message. A function is there. Okay. And what I do here, I'll take a local array and give it hello world. Okay. And for example, I give him 20 and I return this string. Okay. And in the main, what I will do, I will take a pointer and I will get this message and I try to print this message where ptr is equal to percentage s, and here I'll take ptr. So what I'm doing here, I'm taking a local array that is stored in the stack and I'm returning this from the local stack area, and I'm getting this in pointer and I'm printing this pointer. So let's see what will be the output. So it's giving me a warning that returning the address of a local variable. So let's ignore this and just run that. So you're getting null. So still it's giving me some warning. But if this warning is being suppressed in the code using GCC flags, so we won't get this warning. So for that, but still it is giving us null without any crash. So sometimes it will work, sometimes it will not. Okay. So this is a one form of dangling pointer that return from a local string. And then the second is, for example, what I do here, I will take a pointer now. Okay. And now what I'm doing, I'm taking the malloc size of char and I'll take 20 bytes here. Okay. So now this is in the heap now. Earlier it was in stack, now it is in heap. Now what I will do, I will string copy msg and then hello world and returning this heap memory. Now I will get this message in this pointer. Okay. So once I get this message, what I will do, I have to free this memory. Okay. So what I will do here, I will free this memory ptr. Till now it's fine. Okay. Now after freeing this memory, I'm trying to access this pointer. because this pointer already have the address of this memory, and I am trying to print this memory again. So I'll copy this and I will print it after this. So ptr after freeing memory. Okay, so if I run it, we'll get hello world here, but after freeing there is no memory. Okay, so this also is not crashing. So we are not getting any code dump or something. Okay, so but it might crash certain instance of time. Okay, so these are the ways how we can create the dangling pointer. If any other pointer is there and we are trying to access this memory, for example, if I have a temp characters temp is equal to ptr, and if I'm trying to access this temp, still we'll get the same problem because ptr memory it got free after this, and now we are getting uh, this dangling pointer here. Okay, so what is the after effect of using this dangling pointer is there may be random crashes, okay, segmentation fault, but sometime it will work. Okay, so it depends on the code. So for a small program it's fine, but if it is a very big program then it is very difficult to debug this. So crash only when optimization is enabled. It means if if we are reusing that memory, for example, once we release this memory, some other variable is using that memory. At that time, we'll get the segmentation file, but we don't know which event is triggering that. Crash disappear when we add printf. So if we add printf, the stack memory location got changed. So sometimes maybe that memory location is not being used by any other variable, okay, on the system. So maybe it won't crash at that time. So crash disappear when the compiler with the debug flag, we enable that debug flags, and sometimes that memory got shifted. So the point here is it depends on the memory that is accessing by some other variable. Because once we free that memory, other programs in the system try to access that memory because it's free there. So at that time, the segmentation fault will come to our code. This is how this problem is generated. So the next part here, if we get this problem, so how to debug this? Because in a small program it's fine, but if it is a very big program, we don't know where we are freeing this memory and where we are uh, accessing this memory. So for that we already have a tool named Valgrind. I have a Valgrind. So before using Valgrind, we just need to compile our code with debug symbols. Okay, for that what I will do, I'll do gcc hyphen g hyphen capital O0, and now we have the file name, for example, dangling.c hyphen o dangle. Okay, so here I am making this to enable the optimization reorder. So there will be no optimization reorder while making this flag enable. So once I compile it, I'll get this dangle. Okay, so dangle, I got this app now. Now I use Valgrind. So for Valgrind, will use like this. So if you don't have in your system, you just need to use apt-get if you're using Linux system. And so the next option will be leak check is equal to full. And next is track origins is equal to yes, and then dangle. So this is the command which we are using to debug the dangling pointer in our code. So these option you can use help in Valgrind to get to know about this option. Okay, so if you don't know, like I'll make a separate video of Valgrind, how to use Valgrind. So in that you will learn. Okay, for now you need to use these flags with this app, and now you have to do enter. So now memory check debugger starts. So here I got the output. Okay, let's start from the starting. So in here, what I have So this memory check debugger got started. Here is a command. We are using this app to debug. Now PTR is equal to hello world. So till here, everything works fine. So after that, we are getting the back traces. So it start from the dangling pointer 33 line at the main. Then we have get message. Then we in the get message we have malloc. When block was allocated, then it goes to main. Then it frees the memory, and this is where the problem is. So it's showing the address. Okay. So if you see the address of, so here we are trying to access the memory that is inside the block of size 20 that is got freed. So you clearly see that after this free, this error is coming, and you need to check like what is there. So you may take the GDP and go there and check what is there, or you can check it visually also. And if you go down, it start giving this traces again and again till it gives you the full summary in which they said, okay, all heap blocks are freed, no memory leak is there because we are using the free. There is no unattended memory that left in the code, but we have one pointer that is dangling. So for that reason we are getting these errors. Let's see in the next video. Thanks.